Ratios. Hi, Olga. So, what are ratios? So ratios, they used to compare one quantity to the same entire quantity, right? Get me? Like liquids and liquids, you know? Uh, yeah, similar things. Let's say you got to mix this amount of candy with this amount of candy too, and you mix it and then it forms new candy, right? Those are ratios, right? So like if you mix 2 pots of juice, or like have you all seen Oros or types of those? Like if like a juice concentrate, they say mix this amount of that concentrate with water and you get a juice. That's a ratio, right? That's a ratio. So ratios can be expressed generally as A is to B, right? Or A will be, right? Something like that. Okay. So when dealing with ratios, we usually write them in the simplest form, right? And in order to do this, we need to figure out what's the highest common factor. We did this before, right? So let's do 2 examples, right? Number 1, got 9. Let's do 15, right? What's the highest common factor here, right? When you figure it out, it is 3. The highest common factor here is 3, right? So you basically divide these by 3. So 9 over 3, 15 over 3. Simple, right? And yeah, the answer becomes 3 is to 5. Second example I'm going to do is 18 to 12 is to 30. All right. What's the highest common factor here? 6. Y'all should, or what I recommend for you to you have to do is, before you follow with me, figure out what the highest common factor is. Use the other methods. The more practice you get, the better. Right? You can use the ladder method. You can use the other method. As long as you find the HCF, we get. Okay. So you divide these numbers by the HCF, right? So 18. That's 30. I'm sorry if you went so wrong. That's 30, right? And this is gonna be 3 is to 2 is to 5, right? This is basically simplifying your ratios, right? Now let's do this example. So a company manufactures energy drinks. It makes 100 liters of water with 20 liters of energy drink concentrate, right? Write the ratio of concentrate to water in form A to B, right? See how they started with concentrate and then water? So we do the same, right? We don't change it, the order. So remember they used 20 liters and they used 20 liters of concentrate and 100 liters of water, right? Now we need to simplify the ratio. Okay, so we have this ratio. So to simplify it, I will here we find the highest common factor. In this case, it's 20. Right? So this gives us 1:5. Right? Let me know if y'all want the paper like this or like this, so which was better, or you don't mind. Okay. I'll do this way. So use the ratio to determine the number of liters of water that have to be added to 3 liters of concentrate. Right? So this means that the ratio we have is 1:5. This means for every 1 unit of concentrate, we need 5 units of water. By unit, I mean liters, in a sense, right? Because that's the unit of use, liters, right? So if for 1 liter of concentrate we use 5 liters of water, all we do is the following, right? We need 3 liters of concentrate in the question, right? So it is 1 times 3, right? And what you do to the left, you do to the right, right? So 5 times 3. So this becomes 3 liters of concentrate, right? And that becomes 15 liters of water, right? Are we good? So at the end of the day, it's if you're using 3 liters of concentrate, you need 15 liters of water. That's your answer. Are we clear? If you have any questions, leave them below. Let's tackle a new question. So Jane and Nandi run a relay race together. The ratio of the distance they each run is 3:5. Right? If Jane runs a distance of 900 meters, determine A, how many meters did Nandi run, and B, what is the distance of the race. Okay? Let's do A here. Right? So this is the ratio, right? This is the ratio of Jane to Nandi. Right? The distance they ran. Right? So if Jane ran 900 meters, and this represents 3 parts. Okay? Right? So this represents 3 parts of this ratio, right? So we need to know what is 1 part, right? These details in maths is therefore, right? So 1 part is 900 meters divided by 3. It's gonna be 300 meters. So 1 part is 300 meters, right? Now, if 1 part of 300 meters, we know that Nandi ran 5 parts, right? Right? So all we do is 5 parts is equal to 2 what? Basically 1 part times 5, right? And 1 part was 300 meters. 300 meters times 5, right? That equals 1,500 meters, right? Good. Now, for part B, there's two methods to this, right? There's two methods. Method 1, you add Jane's part to Nandi's part, right? So Jane ran 900 meters and Nandi ran 1,500 meters. And this gives you 2,400 meters, right? Simple, right? Method 2, and this is the method I prefer, good, because you are able to apply it in many more situations, right? We know that Jane ran 3 parts and I ran 5 parts, right? That means there were 8 parts to the race, right? Jane ran 3, Nandi ran 5, 3 plus 5 is 8, right? There were 8 parts to race, right? So this race had 8 parts, right? And we know that 1 part of this race is equal to 200 meters, right? So all we do is saying the total distance is equal to 1 part times 8, right? So 8 parts, right? This is 300 meters times 8. Gives us the same answer, right? I prefer this second method, but do what works for you, right? Do what works for you. We'll look at one more example, right? A factory which produces cinnamon buns mixes cinnamon and sugar in the ratio of 3 to 2. If the company uses 10.5 kilograms of cinnamon in one batch, A, how much sugar is used in one batch, right? And B, what is the total mass of cinnamon and sugar in a single batch of buns, right? I'll put this aside. A. So we know that the ratio of cinnamon to sugar is 3 to 2, right? Now, how much sugar is used? We know that this 10.5 kg of cinnamon is used, but we don't know how much sugar is used, right? 10.5 kg represents 3 parts of cinnamon. We need to determine what is 1 part worth, right? So 1 part is 10.5 kilograms divided by 3, which is 3.5. Okay, right? So we know that 1 part is 3.5 kilograms, right? And sugar is 2 parts. So sugar, therefore, 2 parts is equal to 1 parts, right? 2 times 3.5 kilograms, which is equal to 7 kilograms, right? And this is how much sugar is used in one batch, right? Now, for D, now there's two methods, right? Method one is simply add, right? The two is the 10.5 from here plus the 7 kg. This gives us 17.5 kgs, right? This is cinnamon, this is sugar, right? Method two is, in this ratio, there are 5 parts. 3 plus 2 is 5, right? So, there's 5 parts. Yes? But we know that one part is 3.5 kilograms, right? Right? So, if we want 8 parts, it's 1 part times 8. It's equal to 1 times 3.5. Right? And this is equal to, right? So the total mass, the total mass is 17.5 kilograms. Right? And this is ratios. This is part 1 of 2. I'll make a part 2, so it's not so long. Okay. I'll see you in part 2.